Okay, let's kick things off with a stat that's honestly a little terrifying. Picture this. Your production RAG system spits out an answer. It's telling you it is 84.9% confident. Sounds great, right? Except the information is totally wrong. Stanford researchers recently looked at legal RAG systems and found that these highly confident AI models are actually failing silently, with hallucination rates sitting anywhere from 17 to 33%. So yeah, this isn't just a tiny glitch, it's a massive fundamental flaw in how we're actually measuring AI reliability right now.
And hey, if you're thinking, well, that's just the startup problem, think again. Anthropic literally documented a massive 6-week degradation incident that impacted a whopping 30% of their users. The culprit? Context window routing errors. What this proves is that RAG systems fail silently, and they do it with a ton of confidence, in ways that traditional monitoring completely misses. Without evaluation infrastructure that's actually purpose-built for this, your engineering teams are just going to be stuck spending days debugging these mysterious phantom accuracy drops.
Welcome to today's explainer. We're going to completely demystify the wild, complex challenge of evaluating RAG systems. Our goal today is to help shift your team away from this endless reactive debugging and move towards proactive reliability. Let's make sure your AI isn't just acting confident, but is, actually correct. Here is our roadmap for today. First, we'll tackle the RAG hallucination problem. Then we'll get into the Bi-Phasic evaluation solution, navigate the top evaluation tools out there, explore the specialized domain challenge, and finally, wrap up with DoRA, domain-oriented assessment. All right, let's jump straight into section 1, the RAG hallucination problem.
So this illusion of confidence happens when an AI gives you an answer with absolute certainty, but it's completely detached from reality. And a lot of this stems from a really common misconception. AWS actually points this out in their documentation. RAG-specific evaluation is fundamentally different from your standard observability platforms. Think about it. Comparing traditional observability, where you're looking at things like latency and error rates, to RAG evaluation is kind of like checking a car's engine to see if the driver actually knows where they're going, right? You can get a lightning-fast response that is a complete and utter hallucination. True RAG evaluation, on the other hand, zeroes in on semantic accuracy and factual grounding.
Which brings us right to section 2, the Bi-Phasic evaluation solution. If we actually want to catch these silent failures, we've got to flip our approach entirely. See, general LLM evaluation usually just looks at the final output quality. But a RAG pipeline, it's really a two-part mathematical process. By breaking our evaluation down into 2 distinct phases, we can pinpoint exactly where the pipeline is falling apart. Phase 1 is all about retrieval quality. Did the system actually find and surface the right documents? Then phase 2 is generation faithfulness. Did the model stick strictly to the facts in those documents, or did it just go rogue and make stuff up? By separating the two, you literally save days of headache trying to guess if your search algorithm failed or if the LLM just decided to hallucinate.
Moving on to section 3, navigating top evaluation tools.
The good news here is that the tool landscape has evolved so incredibly fast to automate this exact biphasic assessment. You seriously do not need to build these metrics from scratch anymore. There's this massive ecosystem out there now with a specialized tool for basically every enterprise architecture you can think of. For instance, you've got Galileo offering their ultra-cheap Luna 2 models at just 2 cents per million tokens, which makes continuous evaluation super affordable. TrueLens natively integrates right with LangChain to run what they call the RAG triad. Then there's DeepEval pushing for shift-left testing so you catch regressions way before they hit production. And if data sovereignty is your main concern, LangFuse has you covered with a self-hosted MIT-licensed on-premise setup. Basically, whether you desperately need low-latency production monitoring or airtight data privacy, there is absolutely a platform out there ready to go.
Okay, let's dive into section 4, the specialized domain challenge. So what happens when we throw these systems into high-stakes, highly technical environments? Well, you hit the ultimate roadblock. If you're building in defense, legal, or biomedical fields, you're going to slam right into a massive cold start problem. Most standard evaluation tools out there rely on generic, Wikipedia-style questions. But in a specialized enterprise, you just don't have that perfectly labeled data sitting around to test if your RAG system is actually working. I mean, you can't exactly download a public benchmark to figure out if your AI truly understands classified defense procurement docs, right? Which leads us to our final stop, section 5, DoRA, or domain-oriented assessment. To tackle this whole cold start nightmare, some recent research laid out a brilliant framework called DoRA. Domain-Oriented RAG Assessment. It's specifically built to construct synthetic benchmarks using just a tiny, tiny handful of expert documents. Let's trace how this actually works. In a recent defense case study, researchers fed a mere 40 publicly available defense documents into the DoRA pipeline. From that incredibly small seed, the framework dynamically spun up over 6,600 highly curated question and answer instances. And we're not talking about basic trivia here. These QA pairs covered 5 distinct practitioner intents: find, explain, summarize, generate, and provide. This guarantees that your evaluation is actually testing the kinds of complex questions real users are going to ask. Now hold on, because generating synthetic data does come with a massive pitfall that honestly gets ignored way too often. It's called the circularity trap. If you use the exact same AI to generate your training data and then provide the test answers, well, it's basically cheating. It isn't learning the domain at all. It's literally just mimicking its own writing style and memorizing the documents. And that is going to wildly inflate your evaluation scores without actually doing anything to improve your real-world performance.
To completely bypass this trap, DoRA brings in a cross-generator solution. The researchers explicitly decoupled the pipeline. What they did was use Anthropic's Claude Sonnet to build the training split from one set of documents, and then they brought in OpenAI's GPT-4o to build the testing split using a totally disjoint set of documents. By mixing up the AI families and using completely separate source texts, they effectively killed that mimicry bias dead in its tracks. And honestly, the data backing this up is just undeniable. They took a baseline Llama 3.1 8 billion parameter model and they fine-tuned it using the synthetic DoRA data. When they tested it under standard retrieval settings, the hallucinations were slashed by more than half. We're talking a drop from 4.44% down to 2.17%. On top of that, the completeness of the answers shot way up. This absolutely proves that synthetic supervision, when you build it carefully enough to dodge that circularity trap, genuinely works, even when you're dealing with extreme domain shifts. You really don't need a massive, expensive human-labeled dataset to drastically improve how grounded your model is. So, to wrap up this explainer, let's lock in these core takeaways. First off, we've got to stop relying on traditional observability alone. Tracking your latency simply will not tell you if your AI is lying to you. Second, implement Bi-Phasic Assessment. You need to be able to independently debug your retrieval engine and your generation model. And finally, if you're operating in a super niche or specialized domain, start adopting synthetic frameworks like DoRA. It is the best way to solve that cold start data problem and actually build reliable, grounded benchmarks. I'll leave you with this final, critical thought to bring back to your engineering teams today. When your AI delivers an answer to a user, is your RAG system actually right, or is it just highly confident? Thanks so much for joining me for this explainer, and we'll catch you on the next one.